Hi, you guys. So I'm going to take a moment and I'm going to go ahead and go over how to go ahead and solve sex-linked trait problems and some of the blood type problems that you guys are going to be seeing in this worksheet. So first thing that you guys need to know is we're going to go ahead and we're going to read the problem. It says, in fruit flies, the genes for white eyes is sex-linked recessive, and capital R means that we have red eyes, and lowercase r means that we have white eyes. So it says cross a white-eyed female with a normal-eyed red male. So first thing to go ahead and to take note of is that females mean that it is XX, while a male is going to be XY. Right, so this is pretty much the basic part of it. Now we have to go ahead and we have to add in that our female is white-eyed, and we're going to go ahead and we're going to represent that by typing in that lowercase r. And the reason why we're going to type in a lowercase r is because the female has white eyes, and the only way for this female to have white eyes is if it has two lowercase r's. So that's kind of one of the things that we mentioned in our cheat sheet. So you're going to go control period, and then you're going to type in the R. I'm going to do the same thing here. Control period, type in that R, and that would be for my female. My next one is for my male. My male has normal red eyes. So since my male has red eyes, I'm going to go ahead and type in a capital R. So I'm going to go control period and then type in, a capital R. And that is appear in a second. Shoot. Give it 1 second. I'm sorry, guys. So we're going to go control period, and then we're going to type in a capital R. Control period. Type in that capital R there. And now we're going to go ahead and now we're going to do our cross. So I'm going to go ahead and I'm going to write my female genes up on top. And again, it doesn't really matter where you put your male or female genes. As long as you put your females on one side and your males on the other, you guys should be good. Okay, so I'm going to go control period and that little R. Oh, that looks funky. Give me a sec. There we go. And then I'm going to go ahead and do the same thing, Shift X, and control period and a little r. Then for my male, I'm going to write capital X, Shift X, and then control period, capital R. And I'm going to make sure that looks okay. And then I'm going to do the same thing for my Y. And then I'm going to go ahead and I'm going to cross these two individuals. So I'm going to put this individual right here. Oops, that's not what I meant to do. Control V. And this individual right there. This individual right here. And this individual right there. Now I'm going to go ahead and pass down this gene for my male. So I'm going to go ahead and I'm going to write, I'm going to put that right there. And I'm going to put this right here. Okay, and then I'm also going to go ahead, I'm going to pass down a Y chromosome. So I'm going to go ahead and I'm going to add in that Y on each side. And I have this. So that is my completed Punnett square. So now I can go ahead and now I can answer some of these questions. It says, what percentage of the males have red eyes? So now I have to look at my boxes that have males and males only, right? So males that have red eyes, so males with red eyes, if I look on there, I have no males with red eyes because they have a lowercase. So I'm going to write 0%. Yes, and males with white eyes, I have 100%. right? And then I do the same thing for females. I look at the genotypes. If it has one capital R, same deal as completely dominant. If it has one capital R, it will be red. So females, 100% red eyes, and then it'll be 0% white eyes, right? And now it's asking for total percent, right? So when it asks for the total, I can now look at the whole Punnett square. So when I'm looking at the whole Punnett square, I'm going ahead and talking about total percentage of the offspring that will be white-eyed. If I look at it, I have 50%, right? Because only these two down here will be white-eyed. Then I said, what total percent of the offspring will be carriers? So you have to remember that carriers means that you're heterozygous, right? And I only have 2 of these guys that are heterozygous, and females can only be carriers. So then I will be going ahead and I'll be saying that 50% are carriers. And the reason why I can say that is because I only have 2 of them that are heterozygous. And the highest amount that I can get off of a total percentage of carriers would be 50, because only females can be carriers, and we have to see if any of those females are carriers. Okay, so I'm going to scooch down to the blood type ones, and I will show you guys how to do the blood type ones next. So please go ahead and watch.